Okay, now from a configuration point of view, specifically in the case of Nexus, the first thing that we would need to do is go to Global Config and turn the link aggregation control protocol on. Because LACP, like other protocols like OSPF or Telnet or EIGRP, it is disabled by default in Nexus. So in Global Config, we need to say that the feature is LACP. Okay, we'll say this also on the other side on 7K7. So globally, we say the feature is LACP. And then at the link level, which in this case is going to be E227 to 28, E227 to 28. And actually, before I do that, let me step back here. I need to check the configuration of the member ports to see that they are identical. So let's do a show run on both of these ports. And we need to make sure that whatever config we have on one interface has to be identical in the other. Because if we were to, like in this case, we see there's a difference between the allowed list in the trunks. If we were to channel these ports together, based on this VLAN that I had previously removed, which was number 77, if the process sees this as one logical link aggregation, and then we have VLAN 77 traffic come in that direction, it means it would get dropped as it tries to go out that physical link. So basically, whatever configuration we have on the member ports has to be 100% identical in order for the channel to form. Now, you could see specifically what these parameters are that need to match between them. If in exec mode, you look at the show port channel compatibility parameters. And you'll see that it's tons and tons of different options that need to match in order for the aggregation to occur, not only in the terms of the configuration, but also in terms of the hardware capabilities of the ports and the line cards behind the scenes. So for example, in the case of the Nexus 7K, you're not allowed to do a channel where one of the members is on an M1 card and the other member is on an F1 card, because they have different forwarding capabilities behind the scenes. Okay, or likewise, you're not able to create a channel if one of the interfaces is in shared mode and one of the other interfaces is in dedicated mode. Or you're not able to create it if there's a difference in the MTU or there's a difference in the speed. Okay, you can see these a little bit more concise output if you look at the show port channel compatibility parameters, pipe include, and then the asterisk. So that slash is an escape character for, we're saying literally, the literal character star. So it's all these different options that need to match before we can actually configure the channel. Most of the time, as long as you look at the running config and you make sure that they're equal, then the members should be able to form in the channel. But in other cases, it will reject it and then tell you why it's not able to form. Like for example, if we went to interface E125 and interface E225 and said channel group 1 mode on, it says you can't do this because there's different capabilities of the line cards between the two of them. So one of them supports fabric path routing, the other one doesn't. So in other words, the M module and the F module, it cannot channel together. We'll see in the case of the virtual port channel, these requirements even get more strict beyond this, because they also have to agree between the VPC pair or the devices that are forming the upstream virtual port channel domain. Okay, in my case here, I'm going to simplify this though. If we just look at the show run interface E227 to 28, and we're going to say in the global config, default interface E227 to 28. So that's going to delete the config and put it back to the default values. Okay, next on E227 to 28, we're going to channel these together. So we're putting them in a channel group. The number here is locally significant, but from a real design point of view, just for operational clarity, you normally would match this number on both sides of the link. But it is a locally significant value. We'll see even in the case of virtual port channel, the number is arbitrary. In this case, I'm going to say that this is channel group 100. And then we specify how do we want to do the negotiation. The modes in the case of Nexus are active, on, or passive. where active and passive, these two mean that we're running LACP. Now, in the case of Nexus with these three different options, there's three possible variations that would form a correct channel. We could say active on one side and active on the other, active on one side and passive on the other, or on and on. So these two active, 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 passive, this means that we are running LACP. This one means that we are unconditionally channeling. The last mode here when we're doing the port channel is on. This is dangerous. If you make a misconfiguration, you can cause a layer 2 loop in the network. So if I set my mode to be on, but for some reason you are not channeling, I'm going to send frames to out both interfaces, and then you could loop them back in depending on what your configuration is for those particular ports. So in a real design, for basically for safety of the config, you would want to run LACP as active on both sides. Okay, so in this case, we're going to say it's active. And on the 5K on the other side, we're going to do the same thing. So on 5K7, let's look at the show run interface E1 6 to 7. And we need to make sure these are the same. So let's say default interface E1 6 through 7. And on those interfaces, we're going to put them in the channel. So channel group 100, mode active. And actually 100 I had previously used, so let me delete, let's say no port channel, no interface port channel 100. And let's re-add these. Okay, actually what I should have done before creating the channel was there is a command that tells you what numbers have you already used. So in a real design, you might have tons of port channels that are already pre-configured. If you're going to add a new one, you need to make sure it's not overlapping like it was in this case. And the way that you can check that is to look at the show port channel usage. So right now it says 100 is already used. If I put that on a different port like E18, it's not creating a new channel, it's saying add them to the group that I had already previously created. Okay, next up we're going to look at the show port channel summary. In this output, there's a couple different flags that we're looking at. What ideally we want to see is capital U in the channel there, and we want to see that the ports physically have a capital P. Okay, this output here, D, basically means that the ports are shut down. So either on my local end they're disabled or on the remote end they're disabled. In this case, that has to do with the 7K because I said to default the interfaces and the default mode of the interface was shut down. But from an order of operations point of view, this is normally how you want to create the channel, is that you shut the ports down on both sides, do the channel config, and then the very last step is to say no shutdown. The reason you want to do that is you need to make sure that one side does not start channeling before the other side agrees. That's where you can cause a layer 2 loop in the network. So if we look at the show interface E1 6 to 7 status, and we look at this on the other side, which if we show port channel summary, and we show interface E2 27 to 28 status, we can see that these ports are disabled. Okay, so let's go to the physical links, interface E2 27 to 28, and then say no shut. Okay, next let's look at the show port channel summary. And now we see the correct output. So it says the physical ports are up in the channel, they are members, and the channel itself is up. Okay, the other output we see here is a capital S. This means it is a switch port, or in other words, this is a layer 2 channel. Now the underlying mode of the link and the channel are two independent configurations. So this means that you can channel a layer 2 access port, you can channel a layer 2 trunk port, you could channel a layer 3 routed port, or you could channel a routed fabric path port. So the protocol that runs on top of it doesn't matter. What we're changing in the channeling is basically at the layer 1 and layer 2 process. So it's lower layers below the access switching or the trunking or the fabric path routing. Now in our particular case, since this is configured as a layer 2 port, let's look at the show interface port channel 100 switch port. It says right now that switch port is enabled, and the mode of the interface is access. Okay, the reason the port is access is because when I defaulted the links, it removed the switch port mode trunk command. So assuming we want the port channel to be a trunk, we're going to have to add that back in. But now the difference is that the channel is created, or once the channel is created, when we go to the member interfaces and we try to make a change, like let's say we say switch port mode trunk, it's not going to allow us to make these changes on the members of the link. And this is an automatic protection mechanism that NXOS has built in that Catalyst does not. In the case of Catalyst iOS, like 6509 or any of the access switches, you can make a change on the members which will cause the member to fail to be a member of the channel. So on one port, if you change the trunk allowed list, that port's going to get kicked out of the channel. In the case of NXOS, the parser is a little bit better with dealing with this because it says now that these links are in the channel, the only option you have for configuration is to put the config at the port channel, and then we're going to automatically replicate it down to the members. So from this point on, we're going to make all changes on interface port channel 100. We'll say the switch port mode is trunk. And we'll also say that our spanning tree port type is network. Okay, that's going to turn on bridge assurance. On the other end, we're going to do the same thing. So on interface port channel 100, we're saying it's a trunk, and we're saying the port type is network. Okay, if we now look at the show spanning tree, what we should see is, as part of the final verification, is that port channel 100 should be listed as an interface in the spanning tree topology. So right now it's not fully converged. Let's say show port channel summary and show spanning tree for VLAN 10. We see now the port channel is now the port channel says that it's running the spanning tree instance for VLAN 10. But one of the things that we'll also notice here from this output is those physical links that we were previously running spanning tree on, where they were, and I'm not sure if we can scroll back that far to see it. It was these two ports here, E16 and E17. The first one is where we were actively forwarding. The second one was our standby port. So this is where this interface we're not able to forward anything out, so we're essentially losing 10 gigs of throughput. But now with the current configuration, E16 and 7, they're no longer part of the spanning tree topology separately. We see them as just one link from the layer 2 process point of view. Now also from a MAC address learning point of view, the MAC addresses will now be associated with the port channel as opposed to be associated with the physical interfaces. Because part of the rules of layer 2 switching is that the MAC address can only exist on one port at a time. The port channel is fixing that by hiding the lower layer 1 details from the upper layer protocols. So we're basically tricking the spanning tree process into thinking it's one link, where at the lower layers we're multiplexing them together. So if we go to send traffic between our servers, so we had a basic ping that was going between server 7 and server 8. And if we now go to the 7K and look at the show MAC address table dynamic for VLAN 10, we see now the MAC address of the server is reachable via the port channel as opposed to the underlying physical links.